about simplifying expressions using trig identities. We're going to look at this particular example. This is off the sheet that I had given you for homework. Let's see, this is actually number 8. I tried to choose one that was somewhat complicated so that you could see the different steps, and if you got confused, you would have this to go back and look over and watch as many times as you need to kind of see the techniques and all of the tips and things that we use to solve this kind of identity. Okay, so the first thing we see is you have tangent of beta over cosecant of beta plus sine of beta over tangent of beta. Remember, there is no cross multiplying without an equal sign, so that shouldn't even enter the equation ever. Okay, the first thing, one of the tips that I've always said is maybe it would help to try to change all of your trig functions into versions of sine and cosine. And so you see here you've got 3 parts that actually don't have sine or cosine. You have a sine here, but the rest of these need to be changed. So what we can do is we can take this and we can swap out using our identities. We can make this substitution, and then you can see here that now we went from tangent to sine over cosine. We went to secant is 1 over sine. We left the sine the way it was, and then we changed the tangent here as well to sine over cosine. We made these 2 substitutions just in place of those. And that's really the name of the game for what we're going to do in Chapter 7. You've got to learn what applies and what goes where. If you had no idea that tangent had a replacement or that secant was the same thing as 1 over sine, then you're never going to ever have an idea of how to plug in these things and simplify them. Okay, so once I've got this kind of substitution made, I really don't like to have fractions over fractions. So what we're going to do is we're going to get rid of each fraction, and we're going to try to just do a keep change flip and try to fix these things. So what I've done was I took the left fraction, and it's the first 2 parts here. You can see the plus sign still divides them. Okay, so you see the top part, you keep the top the same, just like you see here. I changed from division, which is originally it was, to multiplication. So we're multiplying by this, and you take the bottom fraction and you flip it upside down, or you take the reciprocal. Okay, I do exactly the same thing over here. This is on the top is sine over 1. That's what you see here, and it's the second fraction is flipped over for cosine over sine. We are going to multiply each of the 2 fraction pieces together. So the left 2 fractions, we'll multiply them together, so you get sine times sine and cosine times 1. And this side you get sine times cosine over 1 times sine. You'll notice something here. I can actually cancel the sine with the sine. On the other side, I can't cancel. But here we can, and so we end up with sine squared when you have to multiply the 2 sines together, the cosine on the bottom. Here we just went ahead and canceled the top sine here with the bottom sine here, and you're left with this with these 2 fractions here. Now if you remember, I'm really trying to make this original fraction, or these 2 fractions, into, at best, or at worst I guess, I want to have no fractions at all left. Okay, so we go back down. So I still have 2 fractions. So what we're going to do is we're going to find a common denominator and combine this into 1 fraction. And you'll see that here, which is nice. You see the cosine and the 1 of the denominator, so automatically that means that my denominator is going to be cosine. Well, since this already has a cosine, I don't need to do anything. So I bring the sine squared, just bring it down. This side, well, I need to multiply the 1 times cosine, so that means I have to multiply the top times cosine. Okay, when I multiply the bottom times cosine, I get the cosine. Cosine times cosine, of course, is cosine squared. And then you have 1 fraction, and if you've already thought about it, you automatically think, okay, when I see some squared trig functions, you know, at some point in time, I should probably reference my Pythagorean identities. And that's what you can see here. So what we did is we took our sine squared x plus cosine squared x equals 1, and I made that substitution. So we took the top part of the fraction and simply replaced it with 1, because that's what it's equal to. And to finish off the problem, okay, we know that cosine, 1 over cosine is exactly secant of x. So we took this whole fraction and replaced the whole thing with secant of beta. Okay? And that is my goal. That was what we were trying to do with simplifying a trigonometric expression.